Hello class, this is a video tutorial on the introduction to index notation. To introduce this idea, I want you to just think about a shorter way to write the following questions. So we have 1 plus 1 plus 1, 2 plus 2 plus 2 plus 2, 4 plus 4 plus 4, plus 3 plus 3 plus 3 plus 3 plus 3. Note that I don't want the answer to these. I want a shorter way to rewrite these questions. I'll give you a moment to think about this. All right, and here we go, in 3, 2, 1. Well, 1 plus 1 plus 1 is really 3 lots of 1. So this is the same as 3 times 1, or 3 groups of 1. Well, the moment I've shown you this one, I hope the rest become very straightforward. 2 plus 2 plus 2 plus 2. Well, this is 4 lots of 2. And likewise with this one, this is 3 lots of 4. So 3 groups of 4 plus, and in this case here, if we count them, 1, 2, 3, 4, 5. This is 5 lots of 3. So these multiplications are a shorter way to write the following questions. Well, these ones that we just seen. So as I've just shown you here, multiplication as shown above is a shorthand way of writing repeated addition of the same number. So in a similar manner, repeated multiplication of the same number has a shortcut as well. So 2 times 2 times 2 is written like this. This is the same idea. It's just a short way of writing it. 3 times 3 times 3 times 3. 3 to the power of 4, and I'll get to this in a moment. And 4 times 4 plus 5 times 5 times 5. Well, that's 4 to the power of 2 plus 5 to the power of 3. So with a new form or a new idea, we actually need a terminology to properly describe it. So if ever you see all the multiplications, such as this is called expanded notation. Index notation is we take the repeated number that's being multiplied and we write it like this. So this is called index notation. So in index notation, the number that's being repeatedly multiplied is known as the base, and how many times it was multiplied, in this case 1, 2, 3 multiplications, that becomes what is known as the index, the power, or the exponent. These are the these are 3 words for the same idea. Well, now that you've seen this, let's express the following into index notation. So these are in expanded notation. I'd like for you to convert these into index notation. I want you to pause and give this a go yourself. All right, so here we go. So in this instance, we can see that 2 is being repeatedly multiplied. So notice the multiplication. So the base, the big number, is 2. And how many times it's being multiplied? So there are 4 multiplications. So this is going to be 2 to the power of 4. So this is expanded notation. And this is index notation. Let's keep going. As we can see here, 3 is the number being repeatedly multiplied. So 3 is the base, and there are 3 multiplications. 3, so 1, 2, 3. Oops. So that is going to be 3 to the power of 3. Okay, so let's keep going here. Now in this one, there's a plus in the middle of all of them. So because of that, you have to pay close attention, because only the repeated multiplications become index notation. So this becomes 4 squared. The 5 stays as it is, and this becomes 5 to the power of 4. And there we have it. Let's keep going with this one. Now notice how in this one, it's all multiplication, but I've ordered it so that the 3's and the 2's are separated like this. This doesn't change anything in that we can simply just count all the multiplications of 3. So that's 1, 2, 3, 4. So this is going to be 4 to the power of, 3 to the power of 4 times, in this case again, we can count just the 2's. There's 3 multiplications of 2. So this becomes 2 to the power of 3. And there we have it. And this last one here, same idea, except now we have algebraic terms. Right? This still doesn't change much, except that even algebraic terms can become index laws. So in this case, again, we'll just count the 4's. This becomes 4 to the power of 2. And this time, because it's algebra, if we can recall that when we multiply algebra, so let's say 3 times k, they just become stuck together like this. 3 times k becomes 3k. For this one, we simply just write right next to it a, because that's the base that we're seeing here, to the power of 3, because there are 3 multiplications of a. And that there is how we write these in index notation. Now, for this, now that we've written them in index notation, let's evaluate them. Okay, so for this, here's just a nice way of evaluating these numbers. So 2 times 2 is 4. 4 times 2 will give us 8. And then 8 times 2 will give us 16. So 2 to the power of 4 is 16. Let's keep going with this one. Same idea, 3 times 3, that will give us 9. 9 times 3 will give us 27. So 3 to the power of 3 is 27. For this one here, 4 times 4, well, that gives us 16. Plus stays where it is. 5 times 5 is 25. It's going to get a little tricky here now. 25 times 5 is going to be 125. And now 125 times 5. Let's use some multiplication methods here. So 125 times 5. 125 times 5. I actually work from right to left here. 5 times 100. Sorry, left to right, 500. 5 times 20, because this 2 represents 20. So 5 times 20 is 100. And 5 times 5 is 25. Adding all of these together, we can easily see that that is 625. And now we're just going to simply add these two together. This is going to be 30 plus 11. It's going to be 41. So it's going to be 641. All right, so let's keep going here. So this is going to give us, well, it helps that we have 3 to the power of 3. If you can see it, there's 1, 2, 3. So these three numbers already give us 27. We just need to multiply this by 3 again. So times this by 3. So 20 times 3 is going to give us 60. 7 times 3 is 21. Adding these two together, we get 81. And 2 to the power of 3 is rather straightforward. Ready? 2 times 2 is 4 times 2 will give us 8. Whoops, times 8. This one's where it's going to get a lot trickier. 8 times 8 is 64. 80 times 8 is 640. And then now we're going to do the 1 times 8, which is just 8. So 81 times 8 is 648. Now as for this last one, a to the power of 3 is an algebraic term. We haven't been given any value for a, so a to the power of 3 can actually not be evaluated, so it stays as it is. However, 4 squared is just 16. So this simplifies to 16a cubed. Right, so that there is how we go from expanded notation into index notation. Got another exercise here. So you can pause and give this a go yourself. And yeah, you can fast forward because this one's rather straightforward now. So here we go. So 2 to the power of 5. Well, this really just means there are going to be 5 lots, not 5 lots of 2. There are 2 written 5 times, so 1, 2, 3, 4, 5. And it's just multiplication in between all of them. There we have it. It's very, very straightforward. That there is an expanded notation now. 3 to the power of 4. Well, that means there are 4 3s like this. And there's a multiplication in between each of these. Very, very straightforward. And likewise for these, there's a plus in the between. So the first set of numbers here is 4 to the power of 3. So 4 times 4 times 4. There's that plus. And then 5 times 5. And that, there it is with its expanded notation. Now let's just evaluate these just as an exercise of arithmetic. It helps actually because if we have 2 to the power of 4, which is this one, so 2 to the power of 4 is 16. All we need to do now is just multiply that by 2. So 16 times 2 is going to be 32. And I'll show you some tricks with this one here. We don't have to just work in a linear manner, meaning 3 times 3 times 3 times 3. These two, 3 times 3, will give us 9. I'm going to copy this multiplication here. And this 3 times 3 will also give us 9. This is a lot easier because we know that, well, I hope we know that 9 times 9 is a straightforward 81. Alright, last one here. 4 to the power of 3. It really helps if we know that 4 times 4 is 16. All we need to do is multiply this by 4. 16 times 4. That's going to give us, well, 6 times 4 is 24. Add onto that 40. So that gives us 64. And 5 times 5 is just 25. Adding these two on, this gives us 89. Alright, so I hope that gave you an insight into the expanded notation and index notation of index laws. Hope to see you in the next video, and best of luck.